Okay, here we have chapter 28, question 1. The question is about a alpha particle that travels through a uniform magnetic field, and we want to know the force acting on the particle due to the field, the acceleration on the particle due to the force, and if the particle's speed changes or remains the same. So the first thing we have to do here is take down all of the values that they gave us in the problem. So we know that the velocity is 820 meters per second. The magnitude of the magnetic field is 0.046 Tesla. The alpha particle itself has a 3.2 times 10 to the negative 19th Coulomb charge and a mass of 6.6 times 10 to the negative 27th kilograms. Okay. And we know that the angle between the particle's direction of motion and the magnetic field is 75 degrees. So we have all these values written down here, and phi would be the angle between the velocity vector and the magnetic field vector. So to find the force acting on the particle due to the field, we will use this equation here that the force due to the magnetic field is the charge times the velocity crossed with the magnitude of the magnetic field. And if we write it down in another way, you get the force equals the absolute value of the charge times the velocity times the magnitude of the magnetic field, and then times the sine of the angle between the velocity and magnetic field vectors, which is phi here. Now, plugging in these values, we get the force to be 1.165 times 10 to the negative 17th newtons. And if we round it to 2 sig figs, because that's what we find to be in the values of this problem, we get 1.2 times 10 to the negative 17 newtons, and that is the force acting on the particle due to the magnetic field. And to find the acceleration of the particle due to the magnetic force, we will use Newton's second law. And if we rearrange Newton's second law here, we can get acceleration by itself, and then we get that acceleration is equal to the force due to the magnetic field over the mass of the particle. So plugging in these values here that we have, 1.165 times 10 to the negative 17 newtons over 6.6 times 10 to the negative 27 kilograms, we get 1.766 times 10 to the 9th meters per second squared, and that to 2 sig figs is 1.8 times 10 to the 9th meters per second squared, and that would be the acceleration of the particle due to the magnetic force. Now, the speed of the particle, the last part of the question, the speed of the particle will remain the same, and that's because the magnetic force does zero work moving the particle, and the particle moves in a circle. So when the particle is moving in circular motion, it will have constant speed. The acceleration is only making it move in a circle. And that's about wraps up chapter 28, question 1. Thank you for watching.